Hello, everybody. Thank you all for coming. I'm here today at London to tell you a short story about cross-compilation in the Scala universe. And to answer the question, is it still worth the effort? As cross-compile is a very broad topic and could be very put in the details, there is also something like cross-build and cross-platform. And I'm going to talk about it a little bit as well. But first, I will start saying a few words about me. Well, of course, I'm a developer, love functional approach of coding, surprise, surprise, on a functional Scala. I'm a big fan of Speedway. Does anybody know what Speedway is? The sport? Yeah, I saw one hand. Yeah, cool. I move in the end, unduly from here. Bartosz Marzlik. Sorry. Yeah. As I said, I get easily distracted by new stuff, interesting stuff like antennas, electronic, etc. That is, for example, a picture of Poland I took by antenna of my own design not long ago. It was in the winter, so that was my wife holding the antenna against the window. So she knew that it was cold that day. Well, what I do for a living is I work at Nusnacker. With our team, we implemented Nusnacker in one of the largest Polish telco, blah, 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 about the Nusnacker and my work, right? You're very interested right now. But what is important is that it takes your job away. So, but in the good way. The boring part of your job. So you do not have to re-implement some kind of logic, change SQLs, deploy it, put on the production one over again with small change. It looks like this. It's open source. It's written entirely in Scala. Well, okay. So few words at the beginning, because we all live in the Scala universe, right? That's a very bizarre universe, because we are creating programs in Scala, and we run it on JVM, right? And the JVM itself was not created for us. It was created for Java developers. And, well, we can use any Java library there is in our Scala code, but what we do, we create the same library all over again in Scala. It works the same way. We only have our API, our functional approach of coding, our libs, well, everything that Scala has to offer. And also, we take inspirations for libraries from Haskell. So we kind of connect these two words, which seems unconnectable. Okay, so if anybody asks me, for example, to create a website in Scala, I will ask him if I can do it in Scala. Website. I will ask him if I can do it in Scala. Or he will ask me, can you write HTML in Scala? The answer is yes. Can you write CSS in Scala? Of course. What about the scripts? Well, I can use the Scala CLI. But he may say that you can run Scala anywhere, right? It needs JVM. Well, we have Scala native, so we can run it everywhere. I do have one slide, brutally taken from Wikipedia, what cross-compiler is and what compiler is itself. What is important on that slide is that compiler translates source language into the target language. And cross-compiler is responsible for creating executable code for the platform other than the one on which it's running. Okay, sorry, I have to go through this first slide, lots of text. Now I have pictures and stuff, so more interesting. So, for example, oh, sorry. It's getting hotter in here than in there. So. Well, what cross-compilation we know is, for example, when we want to, as you mentioned, compile Scala to 2.11, 2.12, 2.13, 3, etc. And we have also the definition, right? We have one platform, we want to create a program which runs on the other one. But we also, that's a classic cross-compilation. But we also have Scala native, which helps us create executables for any platform we want, thanks to the LLVM. And we also have Scala JS, which translates Scala code to the JavaScript. Right. And that is not only cross-compilation, but the programs created that way are cross-platform. And there is some abstract part I'm going to talk about. If we consider cross-compilation as a big box, so we put some stuff from one side and we expect something on the output, can we consider ChatGPT to be cross-compiler? Well, it's not cross-compiler by definition, right? But, well, I've asked him to implement, to translate Scala method, JavaScript method from Scala method. And he done the same work that Scala JS did. So, sorry, that's kind of abstract. Just wanted to show you that we can understand it differently. But what is important is that cross-compilation is just another layer. Just like schema or other things, there were many talks about generating code this day. So that's just another tool that's supposed to hide complexity from us. So, okay, as a summary, we have Scala, which compiles to Scala native, Scala JS. And Scala native create executables, which we can run on different platforms. It is fast, gives smaller memory footprint, and do not need JVM to run. And about Scala JS in a second. Okay. So I suppose that every one of you here is a developer who wrote backend as well as frontend. And the most exciting part of our work is when we can start a new project. We can choose what we want to work with. So on the backend, for example, we can choose to work with Scala, let's say Akka, maybe not now, but let's say Akka, Tapir, Zio, or Cats type level, right? Or not together maybe, or if you are brave enough, so you can try it. And you have to create some kind of data on the backend. And frontend, well, we might think about different approaches, technologies, but frontend almost always runs on JavaScript nowadays, and it's still the fact. But we have to hide it under TypeScript, because it looks awful. Nobody wants to write in pure JavaScript. So we have a lot of different libraries in there to help us write a frontend from not our stack. We have to learn this stack from the beginning or remember it, go to it all over again. And well, we have to create this data on the frontend as well, all over again. I know that there are tools to create it for us, but still those are a separate concept, maybe even repositories. Well, if we change something on the backend, for example, name of class or field, we may find out that this error is somewhere in the console log. And you have to go to the backend, to the front end, find out what is going wrong. And well, we can learn front end, right? We do crazy stuff in Scala. We can learn some libraries on the front end and try to keep in touch of them. But in NPM, in one day, there is 880 packages published. That's 36 per hour and 15 by the end of my session. New packages, and not packages like 12.1, 12.2. Those are not counted in. It's based on this guy who scrubs these repositories every day. Okay. It was not a problem that we discovered. It's not something that Scala JS firstly solved, that we can some kind of put a layer on top of JavaScript. There is a lot of different approaches to hide complexity, not primitivity of JavaScript under different languages, frameworks, etc. So, one may say if that's all we need to create the front end, to create something that user can work on. Well, I would say yes, because I create ugly web pages. But if you need something more sophisticated, you can use anything from these fancy boxes and hide it under Scala JS, under facades. So Scala JS at the beginning was not looking good, right? The hello world example waited 16 megabytes just to print something to the console. it was buggy, it was for enthusiasts only, and poor interoperability. And I'm not showing you this slide to point out that that was bad. I'm showing you to never give up because, well, it's like TED Talk, to never give up. But it was the third attempt to create a tool like this. And this one only succeeded. So, well, how the usage of Scala JS and Scala Native looks now. It was dropping down, right? It was going down through the last years, but still, in 2018, it was about 9% of Scala users. But what is sad about this slide is not that usage was going down and then up as Scala 3 was released. It is because this downgrade in the Scala JS users was connected to the number of Scala developers, because it was going down as well. So we may say that this percentage of the Scala users was still the same, but the Scala, not percentage. Sorry, no, I've done it wrong. It was not the Scala JS was getting bad and the users left it, but new Scala users came in, and the one that used Scala JS before switched to different language. And well, as Scala 3 was released, the number of the users increased once more, but not only because Scala 3 was released, but also because Scala JS nowadays and few years before is a very strong tool that, based on Scala text, more than 30% of libraries compile to Scala JS. I think that's one of not many things that Zio and type level agree on that is worth to compile to Scala JS and Scala Native. And Scala JS has 0 bugs. There is no bugs in the code. Well, maybe that's because 50% of all the codes are tests. It's about 100,000 lines. Yeah, 80,000 lines. So, you remember that slide from just before, and JetBrains just published, like 1 week ago, the state of the developer ecosystem, and the users of Scala JS increased significantly. And Scala users are still on the same level, but they need just 2 more years, 3 more years. I think so, because they are just a few years behind Scala JS. Well, okay. This slide I've prepared to convince you that it's good to cross-compile Scala to JavaScript. But, well, there were many presentations today, and will be in the next days, why Scala is so awesome, right? So you have answer in there. You can use Scala to write front-end, right, in a type-safe manner. And, well, for me, that's the most important point. But what is very important is that you have shared code. That means that if you write some kind of classes, definitions, etc., you do not have to copy-paste them both on the backend and on the frontend. And why Scala JS might be a good fit for you is, for example, interoperability. That is a JavaScript code. And usage of some kind of class, HTML, HTTP request. And this is the same code, the same not the same code, but the same usage in the Scala code. I can save you time. There is the difference is 3 equal signs, semicolons, and well, in the app they are using vars. But we can use vars in Scala. We do not do that, but we can. So what is cool about it, that we can interop with JS libraries as we would write code in the native Scala. And it looks the same in the same time. So that's pretty cool. But we have everything that Scala has to offer in the meantime. So you may also wonder, how do we, for example, generate HTML? How do we write it? Well, there are many libraries out there to do that. For example, Laminar or Scala JS, React. And, well, I don't know how about you, but it looks very similar to me as normal HTML. Both libraries are very cool, so I think that you should try Laminar first. But there is also Tyrian, very popular as well. I think there will be talk, I don't know if today, but maybe in the next day, about full stack Zio, and I think the Tyrian is used in there. There is also Outwatch, Udash, or Slinky, as you prefer many. Okay, so to name a few libraries, those are that. And, well, that is, Scala JS was cool until, and as Scala 3 was released, we have cool stuff with it as well. For example, top-level definitions, that is as we would write facade in Scala 2. For example, we have a JavaScript method defined in the global scope, right? And we want to use it inside our Scala code. So we would have to put it in some kind of artificial global object that has nothing to do with our code. But in Scala 2, we can just define top-level definition and say how it should work. That is called the facade. It's, I think, the simplest example of facade there is. What we have here is that we are saying to the Scala JS that this method can be executed, connected by the name of popup, and you should look it in the global scope. And, well, the method of the definition, as you can see, is JS native. So we do not declare any method at all. The method, the definition of this method, will be taken from the JavaScript. But we have usage in the Scala environment in a type safe matter. Well, what is more is anonymous class interface, which help us to pass out, for example, properties to our method. Like, for example, you have 10 properties, you want to pass only one of them, or 2 or 3, etc. You would have to call from the name our trait to create an anonymous class. But in the Scala 3, you do not have to do that. That's simple simplification, but it makes our code less complicated. What is more, we have union types, and union types in Scala 2 were also available, but in the Scala 3, we have native union types. So everything works as it should, because in Scala 2, union types for Scala JS was abstract concept, which sometimes created confusion. For example, in the pattern matching. And in the Scala 3, we do not have to worry about that, because it's going to work. And well, those are a few things based a little bit about Sebastian's talk about best features of Scala 3 for Scala JS. But there are also many different things, like support of directly inside the Scala 3 compiler, rather than an external plugin. There is also a thing that we can use Scala 2 libs inside our Scala 3 code base. So that's pretty cool as well. Okay, so what completes cross-compilation in Scala is cross-project. It is great that we can produce JavaScript code. It is great that we can use Scala both on the backend and both on the front end. But since we have Scala code both on the front end and back end, can we share code as well? And, well, we can. It's as simple as that. All we have to do is add SBT plugin or any other build tool you are using and define your project that way. Thanks to that, we are going to have project structure with JS, JVM, and shared. JS is responsible for the Scala JS code, the code that is going to be compiled to the JavaScript. JVM is native Scala application. And shared will be connected both to JS and JVM, so we can reuse that code. We can write, for example, type-safe API, classes, for example, validation, helper methods, everything you want in shared folder, and we can reuse it both on the backend and both on the front end. So, from the example I've shown at the beginning, which looks fancy, right, a little bit, etc. So we can create fancy presentation slides to the CEO or the board or the client that we are using lots of different technologies, libraries, etc. Well, but we can replace it in our stack that we know, and we can maintain it better. So do something like this. Then when we have our shared base with the Tapir for Safe API, Zio, Quill, and everything is connected. So when we change something in the definition, in the shared, it's going to propagate to all the other parts of our application. Well, so why cross-compilation using Scala JS is not always a good idea? That was obvious joke. Sorry about that. Well, there are a few things why it's not always a good idea. Because, well, I've pointed out a few things at the beginning, but then I realized that only one of it is true. That is limited pool of developers, right? Because we are like dinosaurs, right? We are on extinction. There is no Scala developers pool that's increasing, but that's different talk, a little bit sadder, sorry. But for example, higher cost in bigger projects, right? If you find yourself that you have to work on front-end, etc., I think that's not true, because you can easily find bugs. You will find them at compile time, and well, in the longer time period, you might find out that you actually save some time and money as well. And there is always this one person. I always find this one person when I talk about Scala JS, when he's just getting goosebumps and don't want to even hear about writing front-end in Scala. So, is it still worth the effort? Well, it was not looking good at the beginning, right? Like with Scala Native or Scala JS, it was not very good tool to use at the very beginning. But thanks to the project owners, like Scala JS, Scala Native, community, maybe you guys who participated in Scala JS, Scala Native, maybe you have a library which compiles both to Scala and Scala JS, or maybe Scala Native, you are contributing, and thanks to that, we can effortless use it now. And that's it. Thank you.